find the derivative of these constants, we're going to use the limit definition, which is limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And since it's a constant, we can't really plug in the x plus delta x for x. So you just have negative 3 minus negative 3 over delta x, which would just be 0 over delta x, which just equals 0. And this applies for all constants, so it's just going to end up being the same for 0 and 0. And the constant rule is the derivative of a constant function is 0. So we just basically prove this up here. So, and we need the limit definition to find the derivative of these. So limit as delta x approaches 0 of fx plus delta x minus f of x over delta x. So we plug in x plus delta x for x, so you get x plus delta x minus x over delta x. The x's will cancel, and you have delta x over delta x, which equals 1. And for x squared, you have x plus delta x squared minus x squared. And you would factor this out, and you get x squared plus 2x times delta x plus delta x squared minus x squared over delta x. And so these x squares cancel, and you're able to cancel out the delta x up here. So you end up getting 2x plus delta x squared, and then you plug direct substitution of delta x, so you get 2x, and that's the answer. To find the derivative of x cubed, you're going to have x plus delta x cubed minus x cubed all over delta x as delta x approaches 0. And so you factor this out, and you get x cubed plus 3x squared times delta x plus 3x times x delta x squared, that's a delta x, plus delta x cubed minus x cubed all over delta x. And so the x cubes cancel, and you can factor out a delta x from the rest, so you get delta x times 3x squared plus 3x times delta x plus delta x squared all over delta x. You cancel vowels, and you direct substitute 3x squared plus 0, those go to 0, this goes to 0, so you have 3x squared, and that's the answer. And for x to the negative first power, you would plug in x plus delta x, be 1 over x plus delta x minus 1 over x over delta x. So x minus x plus delta x times x plus delta x. You get this by getting same denominators and multiplying 1 over delta x. And when you simplify that all out, these canceling all out, you would get negative 1 over x squared, which you can be rewrote as negative x to the negative second power. The power rule is stated that if n is a rational number, then the function f of x equals x n is differentiable. And d over dx is to the n equals n times x n minus 1. And this is a shortcut for the next part of the video. To find the derivative of x to the 7th, you just bring down the 7, x to the 6th. And for y equals 1x cubed, 1 over x cubed, you change this to x to the negative 3rd, and y prime equals negative 3x to the 4th. Negative 4th. And you can rewrite it as negative 3 over x to the 4th. And for the cube, for c, you can rewrite it as x to the 5/3. G prime of x equals 3/5 x to the negative 2/5, which is 3 over 5 times x squared, the 5th root. And the derivative of 3x squared is 6x, and the derivative of 4x cubed is just 12x squared. And the constant multiple rule. So this is the constant multiple rule, and this is how we're going to prove it. So you're going to use the limit definition. Limit of delta x approaches 0, c times f of x plus delta x minus c times f of x all over delta x. Thus, we would just factor out a c. Minus f of x over delta x. C times f of x plus delta x minus f of x all over delta x. Just simplifies into c times f prime of x.